Hello, and welcome to Backer Breaks It Down. So in this lesson, I want us to look at something called a reference angle, because being able to find reference angles is a skill we will need to find the exact value of a trig function at a special angle. Okay, so what is a reference angle? So on this screen here, I'm asking what is the measure of the acute angle formed by the terminal side in the x-axis? Because that acute angle is the reference angle, okay? And so in this diagram, our reference angle is this angle formed, like it says, by the terminal side and the x-axis. So I want to know what the measure of this angle is. Now the whole angle has a measure of 250. So what would be the measure of that little acute angle there? So you're thinking 70. Okay, that makes sense because as soon as it reached the negative x-axis, our angle had gone 180 degrees. In order to go a full 250, it would have had to go 70 degrees more. Okay, so if we simply go 250 minus the 180, we get 70, and that's our reference angle, and it's also how much further we went beyond the 180. All right, I like the way you think. What do you think about this one? So this time our reference angle is still the angle formed by the terminal side and the x-axis, so we're talking about this one. The angle that they've drawn for us is negative 315 degrees. You don't think in terms of negative angles all that well? Neither do I. So we can totally turn the negative 315 into its like positive coterminal equivalent by simply adding 360. So if I do that, I'd get like 45, right? Or 55, let me think. No, 45, sounds about right. So like a 45-degree angle would have the exact same terminal side. So you're like, that's the reference angle. Okay, all right, so far so good. So in this one here, we have a 655-degree angle, and I'm still interested in that reference angle, which is the angle formed by the terminal side and the x-axis. I'm interested in that angle right there. So you think 655 is a bit too big? Okay, so we can go coterminal, and we can subtract 360. And so that would give us, let's see, I think 295. I don't know. I want to be for sure, but I can't seem to find my calculator, which is awesome, right? I just found it. Sorry about that. 655 minus 360. Oh, I was right. How about that? 295. Okay, so like basically if we had just gone like, we didn't go that one extra rotation, we would have ended up at 295. So what are you thinking? Yeah, it was almost like 2 full rotations, right? We were just kind of shy of hitting that 360. So like if I had gone like just this little bit more, I would have been at 360. So the question is, what is that just this little bit more? Well, if I go the 360 minus 295, I realized that I was like 65 degrees shy of reaching that 360. Okay, so that seems to fit what that reference angle would be. Okay, so what you kind of just witnessed here is kind of like some reference angle rules and tidbits. Like clearly if the angle's too big, like it was here, or too small like it was here, we should go coterminal and add or subtract 360, okay? And it was also like helpful to us to be in between 0 and 360 because like we all seem to think best with angles in between 0 and 360. And then we also kind of used the 180 and the 360 degrees is like, I don't know, to help us kind of like figure out like how much further did we go, or like what did we fall short of hitting, you know, kind of like that. So let's generalize this and come up with some rules that are going to work given any situation, okay? So we all agree that we think best in terms of 0 to 360 degrees. So you know what? If you need to, go coterminal and get in between 0 and 360, because honestly, you want to know what quadrant the angle will terminate in. And then these rules here are written for angles in between 0 and 360. So if we're in quadrant 1, our reference angle will equal our angle. If we're in quadrant 2, our reference angle will equal 180 minus theta, theta being our angle. In quadrant 3, our reference angle is theta minus 180. And in quadrant 4, our reference angle is is 360 minus theta. So we need to be in between 0 and 360. We need to know what quadrant we're in, and then we can apply the proper rule. So 210 degrees. Like, I know that this is in quadrant 3, and you should too. And our rule for quadrant 3 says theta minus 180. So if I go 210 and I subtract 180, I get 30, and that is my reference angle. Easy. In problem number 2, the given angle is negative 240 degrees. And if, I don't know about you, but that's a bit too small for me. So I'm going to go coterminal, and I'm going to add 360. Okay. And so that gives me 120. Yeah, 120 degrees is in quadrant 2. So I'm using that rule of 180 minus 120. And I'm getting 60 degrees. Excellent. That's our reference angle. And problem number 3, our angle is 7 pi over 4. Now, I don't know about you guys, but like, I'm okay with radians, but I'm not like stellar and confident with them. So I'm going to convert this into degrees. Okay, so I'm going to get like 180 over pi, right? I'm going to like figure this out. And so I'm converting it, doing my calculations. I got 315. And I know that 315 is in quadrant 4. And I know the rule for quadrant 4 is 360 minus theta. So I'm going to have a reference angle of 45 degrees. So that's how you find reference angles. First, get your angle to be in between 0 and 360. Identify what quadrant it would lie in, and then use the appropriate rule. And that's how Backer breaks it down.